In this video, we're going to talk about how to do code coverage with OpenClover and Jenkins. Code coverage is a metric that's used to measure the thoroughness of a test suite. It also helps in determining if all of your code, not just some of it, is fully tested. By including a code coverage tool like OpenClover along with your Jenkins pipelines, you'll be able to determine if the code that you are building and testing is a candidate for release based on the coverage requirements that you need. Here's where we're starting today. I have a Jenkins LTS controller version 2.303.1. When it was installed using install suggested plugins. And attached to this agent, I have an agent that's based on Linux. There is a link to a gist in the description of this video that has links to all of the content that we're going to be discussing in this video. As I just recapped in where we're starting from today, one thing I forgot to mention. I have already installed a plugin, and that plugin that I installed is the Clover plugin. So if we take a look at installed and I type Clover, you're going to see that the Clover plugin is installed. It's version 4.12.1 at the time of recording. And what this plugin does is it allows us to bring in the OpenClover reports into our Jenkins builds. I've also got a sample repository that we're using today. And what it is I have forked the platform labeler plugin. It's the Jenkins plugin. And I have created a Clover branch. So I'm not going to be following the standard build processes for a Jenkins plugin, but I'm using this plugin as an example of what you would do within your own environment. The primary reason why I selected this plugin is it has a reasonable number of tests. It's about 100 tests, and it runs pretty quick, and I didn't have to write all this code myself. Now, the only files that I have added to this branch for this plugin are 3. I've added a Jenkins file Clover 1, a Jenkins file Clover 2, and a Maven settings. Now, in the Maven settings, I've added in a plugin group to be able to pull in the Maven Clover plugin. Let's take a quick look at our Jenkins file Clover 1 just to see what's going on. It looks pretty simple. I'm just going to do a Maven batch mode clean, and then Clover setup, test, and then Clover aggregate, Clover, and then I'm passing in this Maven settings, which helps us shorten up the Clover references here within our Maven goals. Once this is completed, then we're going to be using the Clover Publisher step to generate the reports that will end up in target site and then Clover XML. And then we also have set some healthy targets, unhealthy targets, and failing targets. All of this information about how to use step and Clover Publisher is included in the Jenkins Clover plugin documentation. So let's go ahead and go set up our job. In fact, let me make sure I'm on Clover. Yep. So I'm going to go ahead and copy this URL. Let's go create a pipeline job. Let's say new item, and I'm going to call this Clover-1 and pipeline. Click on OK. Let's go over here to pipeline from SCM. Click on SCM, put in the URL. We are building off of the Clover branch, and the script that we're building is Clover-1. Okay, all of that looks good. That is correct. Let's click on Save, and let's click on Build Now. Now, this will take a few moments, so I'm going to fast forward through this, and I'll join you back once the job run has completed. And now that the job is finished, let's take a look at a couple of things here just to keep in mind as we move through the rest of this video. We can see here in the test block, we had 140 tests run. Okay, I was a little under. I said about 140 tests. And then once we get down to the end here, after the build success, then we're publishing the Clover coverage report and HTML report and the XML report and coverage results. So where do we see these? Well, let's click back up on 1 in our breadcrumb. And we can see here that the OpenClover code coverage, say that 3 times fast, is about 95%. So that's not horrible. But let's go back up here to our top and look at Clover 1. We can see a little more detail here. We can see methods are covered at 100%, conditionals at 88, and statements at 96. So all in all, not too bad. And if you look over here on the left-hand side, you will see an OpenClover HTML coverage report. We'll visit that in just a moment. Let's go back into 1. And let's take a look at the OpenClover summary report. And here we can see all classes, breakdown by package. We can click into this, and then we can see that, if I had to guess, probably this platform labeler global configuration is probably the worst from a coverage perspective because it's 100 here, 100 there, but only 50 here. Just based on the red, that tells us how much coverage that we might be missing. Now, in our numbers, these are probably okay. I mean, if I have overall coverage in the high 90s, 96%, 88%, 100%, what was the average again? We saw that a little bit earlier. We can see that we're completely covered in method conditionals. Where is our overall? Let's remember where that overall is. Let's go back here to Clover 1, and we can just see here, based on this, the total coverage is 95%. Easy to remember that math. So overall, all methods are covered, only 88% of our conditionals are covered, and only 96% of the statements are covered. So this is interesting. We can drill in, we can take a look at a summary report based on a per build scenario. But let's go back to the top of our job, and we can see it in other places as well. But let's click on this OpenClover HTML coverage report. And let's see what happens here. Loading dashboard. Loading dashboard. What's going on here? This is a scenario where this plugin is just a little bit old. In fact, if we go back and take a look at our timing on this plugin, at least age-wise, we are at roughly, let's type it up here. Clover is, oh, the date's not even here. Okay, well, let's just click into it. Well, that wasn't the right one. Here, let's go take a look at it this way. Clover. Let's go to here. Okay, we're going to open up the plugin. We can see it's about 3 months old. But something's going on. Why can we not see what we think to be a dashboard? If you were to take a look using developer tools in your browser, whether that's Firefox or Mac or whatever browser you're using, you would see a lot of 403s. What you're hitting here is a problem with a resource URL. If you were to go back in time, there were some security fixes made to Jenkins core around CSP. Now you could disable CSP, which would make your Jenkins controller not so great from a security perspective, or we can use the resource URL. So how do you do that? Well, let's go back over here to our controller, click on Manage Jenkins, Configure System. And once this renders, we're going to go down to a section here called serve resource files from another domain. And in my case, what I already have created is another domain that's pointing at my Jenkins IP address. So my Jenkins IP address is a 192.168.32.13. I believe that's the IP address. I've set up another DNS entry for resources-Jenkins. This is all for security. So what we're doing is we are creating this reference. So this is resources Jenkins. Now it says it failed to connect to resources Jenkins on my controller itself. I don't have a DNS entry for resources Jenkins. So the controller is not aware of this name, but my browser is aware of it. So what's going to happen when our page starts to render, that dashboard page starts to render, instead of it rendering as Jenkins 8080, it's going to render it as resources-Jenkins 8080. Let's go ahead and click on Save. Let's go back over here to Clover 1. And let's click on now OpenClover HTML coverage. And now we see our full report. And if you take a very close look to this, you'll see resources-Jenkins 8080. So it was from a security perspective that it wasn't allowed to be loaded up. We could have disabled CSP. We chose to leave all of the CSP by default, and we included instead a resources URL. Now, let's take a look at this, and let me zoom in just a little bit. Where are we at? Right about there. Okay, so this actually gives you some very interesting information, still basically the same information that we saw over in our summary, but we can get a lot more detail. A couple of things that are interesting here. The top 4 project risks are, if you were to take a look at it just from this sort of cloud sizing of items, like a word cloud. Platform details tasks looks pretty big. We have some colors here of label config, descriptor impl. There's all sorts of different information that we can use here. In fact, if you go across the top tab, you can see application code, and you can drill from there. You can see test code, gives you all the information, test results. Top risks, again, sort of a word cloud thing of, oh, this is probably the one that's a lot of trouble. We'll come back into that one in just a moment. Quick wins. Okay, platform details task. That would be a quick win to get our bad number down, get our code coverage number up. So, and we can also take a look at coverage tree, which is big blocks. Okay, let's go back over to our top risks. Let's click on platform detail task. And if we look here, the source code is here. And as we scroll through it, it gives us information about what's potentially causing a problem. Anything that's green means it's covered. Anything that's not green means it's not covered. In fact, this one right here for return arc, if we hover over it, it says line 132, column 9, statement not executed. That means it was not in any of our test paths. And if you were to scroll through some more, you would find, I think there were a couple of others once you get down a little bit further. Yeah, so there's one here doing a comparison. So false branch executed 0 times. So I'll let you go through this with your own project and sort of see, okay, what items aren't being covered in my code. Since in this video, I'm using a static agent connected to my controller, I can easily take advantage of a feature that OpenClover provides that's called test optimization. What test optimization does is it allows a build to potentially complete faster because tests will not be run for code that wasn't changed. So as we saw in our example earlier, we had 140 tests. If I made a change just to one line in one class, maybe in platform details tasks, and 138 of those tests had nothing to do with that, then the only test that should be run would be the 2 tests that cover that task. So this is a way to potentially speed up your job runtimes when making changes to only small parts of your code. So how does Clover do this? Well, since Clover records what tests match to what lines of code, there's basically a database. So it's able to map what code did you just change, and then compare it to tests, and then it, through Maven, is able to determine which tests need to be run. So you remember that Jenkins file 2 that we had? Let's go take a look at that. So if we go back over to GitHub, let's take a look at Clover 2. If you were to take a quick look at this, in order for the test optimization to work, there are 2 Maven goals that you need to include. Now, OpenClover also works with Gradle and a few other build tools, but today we're using Maven. So if you're using Gradle or the other ones, you would have to figure out which goals that you would need to call. This line at line 6 is exactly the same as what we just ran before in the Clover-1, except for 2 goals. We've added Clover Optimize, and we've added Clover Snapshot. So other than what we see here, just Clover Snapshot, Clover Optimize, this Jenkins file is exactly the same. So let's go back over to our controller. Let's get back here to Jenkins 8080. And let's create a new item. I'm going to call this one Clover 2. So we're starting over in a completely new job. It's going to build completely fresh. And let's watch what happens. We would expect the exact same thing to happen as what we just saw in our first run with our -1. But let's take a look at what happens with this -2. Because if in your suite you've got lots and lots and lots of tests, this could be a very pleasant surprise in speeding up your time. Let's say your test suite is huge. Let's say that it takes 30, 45 minutes. If you made one small change and you didn't need to run the whole suite, you just needed to cover just the test for the change that you just made. And that test suite that was taking 20 to 30 minutes before now is down to less than a minute. How much time is that going to save you? Let's see what this is like. Let's click on Build Now. And what I'll do is fast forward through this until it's at the end, and then we'll come back in. Okay, so let's take a look at what happened here. If we remember from Clover 1, there was a 140 test run. Here there's only 131. Why? I can't explain it. I have to go and dig and compare these two outputs for test. So our starting point here is 131. We go through the rest of this. We can see here that it's creating the reports and everything else appears to be fine. We can notice here there was no snapshot file found. So we're creating a new file at Home Vagrant Agent Workspace Clover 2. That's the reason why I created a new job. And there's a .clover directory here. This is the reason why I said it's a good thing that I have a static agent, because I need to keep this file around because the snapshot is there, so it's able to do the diffing between each job run to determine which tests need to be run. Now, in the documentation, and in fact, it goes on over here to clover.snapshot, it's sort of wrapped around. In the documentation for OpenClover, you can relocate where the snapshot file lives. Now, I'll leave that up to you as an experiment to figure out, okay, how do I want to do this if I'm not using a static agent? That's going to be your call. So what we have here is 131. We've now written a snapshot, so we're ready to roll. We've done our first run, so we now have a baseline of all the tests that are captured now inside of OpenClover. Before we make any changes, what I want to do one more time, just so you can see what happens, is let's go run the job again. No changes at all. We're going to click on Build Now. Let's watch 2 as it goes through. Okay, so that finished up. It updated the snapshot, sort of the end, but let's go back up towards the top, because this is what's interesting. I'm going to look for Optimize. So there's our call for Clover Optimize. Let's go to the next find. And right here in the info, we can see that Clover estimates having saved around 31 seconds on this optimized test run. The full test run takes about 31 seconds. So if we go back and up and take a look one more time, there should be a reference in one more place. Let's see if I can find it. It updated the database. So in doing this optimization, let me find one more time. I believe there's one more optimize here. Here we go. Nope, that was it. Okay, good. So as we scroll through the rest of this, what you'll notice, watch for that test banner, you'll notice that it doesn't even exist because all of the test runs were suppressed during this run. Let's go make a change to one of the files. So I have VS Code set up here. I am inside of the platform labeler global configuration. I just picked a file, doesn't matter. I'm going into the configure method and I'm going to type in int I equals 0. It shouldn't break anything, right? You would hope. Let's click on this. Let's add that file. Add new math. That's staged. Let's see if it commits here. There we go. Let's push that change up. Okay, we've pushed that up. Let's go back over to our job, Clover 2. Let's do a build now. Now you may notice while that's starting to run that our charts are messed up. And if you think about it, that sort of makes sense, right? Because we did not run any test on that second run. We had 131 tests on the first run, and then we had 0 tests on the second run. So we would expect these charts to look a little weird because there were no tests run. So if you decide to go down the test optimization route, you're not going to be able to rely on these charts. The charts are going to be lying to you even though everything's actually okay. Let's go back over to 3. Let's look for optimize here again. What we should see here is it created a new database. It updated the existing database. Clover estimates having saved around 10 seconds on this optimized test run. Remember, it's figuring out what changes were made. Let's go down and see if we have a test block this time. Now, in theory, we should because it found tests. So here's tests. And in this case, we had 14 tests run. Not 131, but only 14. Because this one line change, this int I equals 0, only triggered 14 different tests. That's it, not the full suite of tests. So instead of taking 31 seconds like it would normally take, if we go back up here to this estimate, normally takes about 31 seconds, we saved about 10 seconds. Why should you care about code coverage for your project? Code coverage is important because it lets you know what parts of your code are actually being executed by tests. If there are parts of your code that are not being covered by tests, there's a good chance that you need to refactor that code or add new tests. If you have any questions or comments, you can reach out to us on Twitter at CloudBeesDevs. If this video was helpful to you, give us a thumbs up. And if you haven't subscribed to CloudBees TV yet, why not? Take a moment, click on that subscribe button, and then ring that bell, and you'll be notified anytime there's new content available on CloudBees TV. Thanks for watching, and we will see you in the next video.